Next, we're going to take a look at how to graph from factored form. Factored form is when you have a set of binomials being multiplied that would give you a quadratic function if you FOILed them. So the first thing we would do is multiply the x by x, and that's where we would get the x squared piece from. It's not in the right-hand column, but we always want to identify if our graph opens up or down when we're looking at a quadratic function. In this case, we look at what's being multiplied outside the parentheses. If it's positive, it opens up. If it's negative, it opens down. Next, for the factored form, we find our zeros. So it says we use the zero product property, that's the ZPP, to find our zeros. Our zeros occur when our y value is 0. That will give us the x values where the graph crosses the x-axis. Remember, zero product property means that if we have multiplication to 0, the only thing that we can be multiplying by is 0. I'm not going to use this value out front. It's -1, and -1 does not equal 0. It doesn't have a variable piece, so that does not help us find our x-intercepts. So I set my two binomials equal to 0, and I solve for my two x-intercepts. So my first x-intercept is -3, subtracting 3 from both sides, and my second x-intercept is +1, adding 1 to both sides. You'll want to write these as ordered pairs so that you understand where it goes when you are graphing. X value of 1 or -3, and then the y value was 0. After we have our zeros, we average them to find the x-coordinate of our vertex. Because parabolas are symmetric, our vertex will be halfway between any 2 points with the same y value. Obviously, our x-intercepts both have a y value of 0, so our vertex will be halfway between our two x-intercepts. So we take -3 plus 1 and divide by 2 to get our axis of symmetry, which in this case is -1. Once we have our axis of symmetry, we substitute that back into the function to solve for y. So we will get a y value of the opposite of -1 plus 3 times -1 minus 1. So we get the opposite of 2 times -2. So the y-coordinate of our vertex on this one is +4. So our vertex is, we had an x-coordinate of -1, and we solved to get a y-coordinate of 4. When we graph, we simply plot all of these points. I'm going to call each of these 2 again. Our vertex was -1, +4. We know that our graph will open down, so we're going to make sure that it does that once we graph our x-intercepts. Our x-intercepts were -3 and +1. We only need 3 points to get a parabola graphed, so now we can make our U-shaped parabola graph. And our graph does open down. As a reminder, our axis of symmetry was x equals -1. Our vertex goes through the axis of symmetry, and our graph is symmetric around that. Finally, we'll find our domain and range. As a quadratic function, our domain is all real numbers. Our range is based on the y-coordinate of our vertex and the fact that our graph opens down. So our range will be less than or equal to the y-coordinate of my vertex, which on this graph was 4. One more example, finding all of the critical information for a graph in factored form. Determine if it opens up or down. This isn't part of the question, but we always want to do that with our quadratic functions. This one, our lead coefficient is positive, so it opens up. Finding the zeros, or the x-coordinates, we're going to set our equation equal to 0. And we'll solve for x. Again, that coefficient cannot equal 0. 3 does not equal 0, does not have a variable piece, so we only have to set those binomials with a variable piece equal to 0 to solve for our x-intercepts, or the zeros of the function. So we have zeros of -2 and +2. Writing those as ordered pairs, we would have -2 for our x-coordinate, and we started by substituting 0 for y, so that's our y-coordinate. Next, we use our zeros to find the x-coordinate of our vertex. So to get our axis of symmetry first, we will add our two zeros together and divide by 2. So this time we have an axis of symmetry of 0, so our vertex will land on the y-axis. In order to finish finding our vertex, we substitute 0, the x value we just found, back into our equation for x, and we'll solve for y. So on this one, we have 3 times 2 times -2, which gives us a y-coordinate for our vertex of -12. So our vertex was, we got 0 for x, solved and got -12 for y. Finally, domain and range. Domain for a quadratic function is always all real numbers. Range will be based on whether or not our graph opens up or down. This one opens up, so we have greater than or equal to the y-coordinate of our vertex.